We are going to see about Euclid's division algorithm. First of all, we'll see about algorithm. What do you mean by algorithm? Algorithm is a process or set of rules to be followed in calculations. Algorithm is a process or set of rules to be followed in calculations. Euclid's division algorithm is based on Euclid's division lemma. If you want to know about Euclid's division lemma, you can check the other video. Now we'll see an example. What is the use of Euclid's division algorithm? So if you want to find HCF of any two numbers, you can use Euclid's division algorithm. For example, so if you want to find HCF of 455 and 42, we can go with Euclid's division algorithm. So we'll go with the first step. In the first step, you have to apply Euclid's division lemma. So Euclid's division lemma will be in the form of C is equal to dq plus r. So to write in this form, first we have to use long division method. So 455, the divisor is 42. How many 42s are there? We can go to the nearer one, that's 42 times of 10, 420. The remainder will be 35 when we subtract. So if I write an Euclid's division lemma, so 455 is equal to 42 times 10, the remainder is 35. So that's the first step. So we apply Euclid's division lemma until we get the remainder as 0. So we'll see the rules later. We know a fact that if there is a common factor for 455 and 42, it must also be a factor of 35. So apply the division lemma for 42 and 35. So again we're going to go with long division, but it's easy. So divide 42 by 35, that is 1 times of 35 and the remainder is 7. So 1 times of 35 and the remainder is 7. Still we didn't get the remainder as 0. So again we apply the division lemma for 35 and 7, which is 5 times of 7 is 35. The remainder is 0. So we got the remainder as 0. We'll decide the HCF of 455 and 42, which is 7. When we get the remainder as 0, particular step will decide the divisor of that step is the HCF of the number what we have started. Okay, this is all about Euclid's division algorithm. To obtain HCF of two positive integers, say C and D, with C greater than D. So here C is 455 and D is 42. So the greatest should be written in the left hand side of the equation. So step 1 is apply Euclid's division lemma to C and D. So we find whole numbers Q and R such that C is equal to dq plus R, less than or equal to, greater than or equal to 0, less than D. So we got 455 is equal to 42 times of 10 plus 35. 35 is less than 42. Step 2. If R is equal to 0, D is the HCF of C and D. But we didn't get R as 0, so apply the division lemma to D and R. So we applied the division lemma to 42 and 35. Step 3. Continue the process till the remainder is 0. The divisor at this stage will be the required HCF. So here 7 is the divisor and the remainder is 0. So we decided that HCF of 455 and 42 is 7. So here the fact we have used in the second step is given. So this algorithm works because HCF of C and D is equal to HCF of D and R. This is all about Euclid's division algorithm.